Hi everyone, we are live. My name is Kurt Kichogin. I'm the developer of Baseledger and also core maintainer of the Baseline protocol.
Hey, my name is Kosti Stefan. I'm also working as a Baseledger developer and also developer on Baseline.
We want to use this time to take you through, explain what Baseline and Baseledger is, go through some Baseledger specifics, and then look into the Lakewood testnet that was deployed since August this year. The main part of the video, or the main cause why we are doing this, is to show you an Excel example where two Excel sheets are being synchronized via Baseledger through a sample use case workflow. And in the end, we just want to share the future plans for on the road to the Baseledger mainnet. So yeah, let's jump right in. In order to understand Baseledger, first we need to shortly explain what Baseline protocol is. It's a standard or a protocol that's being developed by companies such as Unibright, Consensus, Ernst & Young. And the idea is that you can have multiple parties who want to exchange and synchronize on some kind of a state while not revealing sensitive information. So that is like a high level description. We will be adding materials that are going to follow this video where you can dive in to learn more. So the Baseline standard relies on some kind of a mainnet where the proofs can be stored and subsequently verified by whoever needs to verify them. And initially this was Ethereum. But as you know, for enterprise use case, Ethereum can be quite costly and slow. And there arose a need for we can call it layer 2 solution, right? And Baseledger is one of those solutions. It's a blockchain which is running on proof of stake with Tendermint as the underlying technology, which is reliable, which is cheap, and which is super fast. And hopefully these properties can make it a net that can be used as a underlying network for storing proofs on Baseline, and that later on exit into Ethereum if that's necessary. Baseledger Council, the organization that's founded with the goal to lead Baseledger to the mainnet, was formed just weeks ago, and yeah, you will get updates on the progress towards the mainnet in the upcoming months. One specific thing that's built on top of Baseledger that we built as part of the Lakewood testnet is the concept of trust mesh. And in order to explain that, basically in Baseline you have two parties, for example, that are exchanging some state, some domain or business objects, and these objects go through some kind of work steps in order to complete a workflow. Right? You can think of it as sending a purchase order, approving that purchase order from another side, sending another document until you have a state which is a business transaction which is settled. So Trust Mesh follows all of these state objects by tracking the business object IDs from the respective systems of record, also tracking the transaction IDs in Baseledger and the suggestions and feedbacks that are being exchanged throughout these workflows. And it stores that in a data structure made of trust mesh entries, so that whoever needs to track how a state object evolved through some kind of a workflow can have a single place where he can see that. And you can also use it to visualize the changes, to do subsequent synchronizations and analytics and so on. This, of course, is available. This data is available only to the participants of the work group, so it's not something that's available to the outside world. We will be providing a link to a more in-depth explanation of the trust mesh as part of this video, and we are going to touch on it in more details in the demo that we're going to show. One final thing before the demo, I'm going to share my screen, is the the Lakewood testnet. So here you see the Lakewood testnet explorer. As I said, it's been running since August. We already above 1,100,000 blocks without any downtime. The idea behind this testnet was to test Tendermint consensus, to test staking, to test behavior of validators, and various other features of the network. We also did some stress testing by trying to manually exclude a number of validators out from the network and then try to add them back to see how does that behave. It looks really good so far as a first stepping stone. Other testnets will come in the future that are going to all be building blocks towards the mainnet. The Excel example is running against Lakewood, and in the GitHub repo of Lakewood, you can see instructions on how to join the network if you want to test it out. So you can join it either as a replicator node and then directly drop proofs against your node, or you can drop proofs via pre-deployed nodes. These nodes are Alice and Bob nodes that we are going to use for the Excel. You just can, in the repo, you jump into the docs, and there you have all the instructions necessary, follow them through, and you should be able to drop the proofs and then see them in the Baseledger Explorer of the Lakewood testnet. So with that out of the way, we can jump into the Excel demo.
Yeah, so I will share the screen quickly. You need to enable the sharing quickly.
Yeah, sure. Just give me a sec. Filter now.
Yeah, now it's possible. Thanks. Yes, so as Ognin said, we will go through the Excel demo first. I will just explain the data you need to put inside the Excel for this to work. There are a couple of sections. First one is called identify. The first entry here is IP of the node, and this will be used by Excel to send HTTP requests. And then we have a JVT token. This was also mentioned in the how to drop the proof doc, but you pretty much can create a user and then get the JVT token by login. So I already have one demo user prepared. So I will just grab the JVT token quickly. And yeah, by getting this JVT, we can put it here into this field. Then the next one is a link to TrustMesh Viz app and Etherscan, and it will become clear shortly how these are used. Next section is workgroup. It contains information such as workgroup ID, name, and key, which is used for encryption of payload, which will also show a bit later. I can add a new workgroup. Then we have two sections of participants into this exchange. First one is your organization with nets endpoint and token. And the second one, pretty much same information about recipient organization, and I will add both to a node database. And important here is that other party, so in this case, Ognin is doing the same on his end. We will show that a bit later. So when all that ready, I can start with a new workflow. Clicking a new gets this row showed here in the Excel, and I can already start with the first work step, which is just we agreeing on last and first name. Then final work step is nickname, and then we will also show what these two links are doing here. So I will put some info here, maybe with some mistakes, so we can demonstrate rejection. So once I click suggest, this goes into waiting for feedback state, and I can also show what TrustMesh Viz now. So this is TrustMesh Viz app on the Bob node, and you can see it. It has one entry in the TrustMesh, which is marked yellow now because it is waiting for for feedback. And now we will quickly see how this looks on the Onion side. So I will stop sharing for a second.
Cool, I'm taking over. Now in my Excel, so while Skos was talking, I also prepared everything on my side. We have the same workgroup ID. Here is the workgroup key, which is used to encrypt all the payload, which later goes into the transaction payload in Baseledger. And also the organization ID with nets endpoints are set up. And now if I say get new, I should be able to get the synchronization request for the first work step proposed by Stefan, and I can decide to reject it because there is an error. With that being provided, the feedback goes back to him, and he can decide to fix the issue and send a new version. So over to you again.
Yeah. So on my side, I can now click latest. So latest is pretty much for doing the manual polling of the new state. So you can see now already I have this rejected here, and I can go and provide a new version or new suggestion. Clicking suggest. So Ogden will now, when clicking latest on his side, he will get again the same info, and now he can approve.
Yep, so I got the new one and I can now say approve. So each of these steps is creating a trust mesh entry.
Yeah, I can show that in the meantime. Maybe
showing
now sharing. So it is the same trust mesh. Now we can see that first one in the work step Excel name got rejected, and I sent the new version, which is now waiting for feedback. You can see 0 out of 1 feedback given. So at the time Ogden gives feedback, approved feedback, you can see this is now approved, and this will get reflected in the Excel as well. So I'm clicking latest, and you can see it is synced. And now I can proceed to work step 2, which in this case is also a final work step. So I can just put a nickname, send a suggestion, and also waiting for audience feedback. And while we wait, we can again quickly check trust mesh viz.
Yes,
And we can see a new work step also reflected here. It has one entry that is waiting for feedback. So Ogden, yeah, I can also click.
No, I just approve.
Yeah. So this gets moved to an exited state, and I will explain that in a second. So first, let's check the trust mesh viz. So you can see now the workflow is completed, and also you can see that every entry has associated transaction hash. So I can click one of those, and it will go to a Lakewood Baseledger net, and you can see transaction in more details. And the most interesting part, of course, as we mentioned, is this encrypted payload. And yeah, this is encrypting the details of trust mesh entry and using the secret key that our group can define. We left it here as visible, but of course this can be hidden here as well. It is using that one, and you can see with clicking latest button was still available because there was some time needed for exit to Ethereum to happen. So exiting is working in this way pretty much when final work step is approved. Merkle tree of all trust mesh entries is calculated, and the root of that tree is anchored to Ethereum. So now if I click show, yeah, currently Robson is taking some time, but we will leave this transaction hash together with this video to check. Pretty much anchoring will happen, and there is a mapping between Baseledger transaction ID and the root proof of the Merkle tree. So yeah, with this, the whole workflow is completed, basically.
Yeah, cool. Maybe you can show another Robston transaction, previous one, or just check, refresh if see if it's
Yeah,
maybe.
so yeah, that makes sense.
Sometimes
So,
it just takes time.
yeah, today we had some issues. I'm trying to find this one. Yeah, you can see we had a couple of others when we were preparing for demo. So this is how they look, and we can see that actually here is a Baseledger transaction ID, and this is the root node proof that I mentioned. So this is the mapping that we are anchoring on the Ethereum.
Nice. Yeah, so the Excel demo will be also provided accompanying this video so that you can try and play around with it. And I believe that's it. We will be, as I said, following with materials. Thank you for your time and talk to you all soon.
Yeah, bye.